right, we are going to talk about which method is best for solving. This is kind of like a little review that we have. I would probably save maybe 3 or 4 lines under each category, and we're going to go through each one. So just the top half of your page. Don't split your page into 4 big sections, because we're just going to go through and talk about which method is best and do a little bit of review today. And you can write these down one at a time if you want to. So we can just start off with our square roots. When can we solve an equation using square roots? When it just has x squared. So when there is only x squared and no x term, we can use square roots. So an example of that, if you wanted to see one real quickly, an example would be like x squared equals 25. Right? There's only x squared in the problem, and we just solve it for x squared like normal, so get x squared by itself, and then what would you do? Square root both sides. And don't forget to put what? Plus or minus. So the square root of 25 is 5. So you solve for square roots when there's only x squared in the problem. You get x squared by itself. You square root both sides. Don't forget the plus or minus. And that was like the first day that we did in this unit. We solved problems like that. So next on our list is quadratic formula. Now you can use the quadratic formula on any quadratic problem. What does it mean to be quadratic? It has to have x squared in it, right? Just x squared. Now, before you get started, that equation has to equal what? 0. So remember how we wrote down ax squared plus bx plus c equals 0. So that's what your equation will look like, and that's how it will start. And then we just plug into the formula, which means we need to sing. X equals, what's the song? Opposite of b. Plus or minus square root. B squared minus 4ac. All over 2a. Now, if you are looking at this equation online, I write it a little bit differently than what you would see online, or maybe if you picked out a different song on YouTube, they usually combine these together. I keep them separate because of what we're going to be doing in our next unit and what you have done in the past. But we plug everything in, and remember, we had certain ways that we simplify this to show all of our work. We simplified what first? Under the square root and denominators. Those two came first, right? And then you simplify the square root, and then you simplify the fractions. So keep that in mind when you're doing these. Show all that work, show it plugged in, and simplify one step at a time. So denominators were first, then under the square root, then the square root itself, then the fractions. And you have all that written down somewhere in your notes. All right, let's go to our next one, which is factoring. Now, factoring is what we did 2 units ago, and we did it a little bit in the last unit. We may have seen it a little bit in this unit as well. But you can only solve by factoring if the problem is factorable. I don't even know if that's a word, but we're going to say that that's a word. You solve by factoring when the polynomial can be factored. But as we saw, not everything can be factored, right? So you can only solve by factoring when it can be factored. Again, not as much in this unit, but we have done it before. So on the test that's coming up on Thursday, I won't have you solve by factoring, but I just wanted to show you it is an option that you could do because we did that on a test a while back. All right, the last one we have is to complete the square or completing the square. Now, I think it is best to use completing the square when the first step is already done. What's the first step on completing the square? A equal to 1. Yeah, that's what I think as well. When A equals 1, then I would complete the square, or when you have a perfect square trinomial. So, oops, I was going to use a different color. So, best when A equals 1, or you notice a perfect square trinomial. My board is definitely freezing up on me today. There we go. Now, can you use any of these methods? You technically can. The only time I wouldn't use like quadratic formula if it's just got x squared in the problem, that would probably be easier to use than quadratic formula. But you could use any of these methods depending on the type of problem that you have. So when you get into Math 3, especially later on, I'm going to let you pick whatever method that you like to use. And some of you may use quadratic formula every single time. And some of you may try to factor every single time. Some of you may have really liked completing the square. But again, on Thursday's test, I'm going to specify which one to use. So I will say, solve these using square roots, solve these with quadratic formula, solve these with completing the square. Okay, so I will specify which one because you do need to know all the types that you have for different types of problems we're going to see in Math 3. All right, for this next slide, you do not have to write these down, but I want you to look at the methods and figure out which one that they use. So we can only see the top two right now, but maybe you can figure out what did they use in Method A, what did they use in Method B. You could probably also look a little bit at C and D and figure out which one's which. So what do you think about method A? What did they use? Square roots. Yep, they got that x squared by itself, and they ended up using the square roots because if you notice, the only thing in the problem is x squared, so they got x squared by itself, and then they took that square root to get the answer. All right, what about in B? Factoring. Factoring is correct. Now, when you factor, you make sure that it equals 0. You take out that GCF, and then you factor as much as possible, setting each one equal to 0. What do you notice about the start of both of these? They're the same, so it's the same problem, but you can, again, use two different methods. Does it matter which one you use? No, you end up getting the same answer. Key thing is with the square roots, don't forget the plus or minus. All right, let's look at methods C and D here. Notice that these two are also the same problem. Well, what do they use in method C? Quadratic formula. That's pretty easy to see. So what do you think is used in method D? Completing the square. If you notice, the x squared starts as a 2, then that's removed, so that's divided. They added a new term on both sides. It looks like it's factored. Then we square root and solve for x. So these are different ways to solve the same problem. All right, very good. Now we're going to talk about different representations of the quadratic equation when the board decides to change. Do y'all have any questions about your test on Thursday? Why? Just because. But don't forget, counting today, there's only 18 more class meetings that we're going to have, and we still have 3 tests and a project. The project will be given out next week. So we got a lot of test grades still that really can influence your grade. Maybe we should just sing the quadratic formula again. Think that would help? Logan, you got a question? Yes. So we have the one on Thursday, and then we have one, our next unit is all about quadratic graphs. So we're going to be doing these same things. Oh, here we go. Y'all go ahead and write that down. So we're going to be doing the same thing in this unit, but we're going to be dealing with the graph of things. And then our last unit, we're going back to some geometry stuff, but we're doing everything about right triangles. So Pythagorean theorem, and you may have heard your older siblings talk about trig, sine, cosine, tangent. That's in our last unit. That's trigonometry. All right, but write down these 2 equations there, and then the 2 problems down here at the bottom. All the problems that we have really dealt with so far have been in this standard form where you have your ax squared plus bx plus c, right? Kind of done that with the quadratic formula. It was kind of that way for completing the square. So we have another formula that we look at, which is our vertex formula. And you may have written things like that in Math 1, but probably not. It was a little extension. Some teachers did it last year, but most of them did not. So in this vertex form, it will actually tell the vertex of the graph. Now, a quadratic graph looks like what? It looks like a U shape, right? And that U shape can open up or it can open down. So the vertex is either the highest or the lowest point on the graph. So if I were to graph this out, it could open this way or this way, and these points are both called your vertex. So if the graph opens up, your vertex is a minimum point. If your graph goes down, your vertex is a max point. And again, we're going to talk about that more in the next unit. But we are going to manipulate some formulas to get them from standard form to vertex form. Now, also what's true is this letter that's with X and this letter that's with K is our vertex because it tells how our graph shifts left and right. Remember how we did the radical unit and we graphed those? So if it said X minus 2, it actually went to the right 2. Remember, it's opposite of what you think. And the plus at the end made it move up if it's positive or down if it was a negative. So these here, HK, are your vertex. Opposite of what you think, and then the same as what you think for the coordinates. So if I have these 2 equations down here, we just look at what's inside the parenthesis and then what's added at the end. So the vertex for this graph would be 2 and 1, because this minus 2 is going to make it move right 2, and this plus 1 is going to make it move up 1. So the vertex would be 2, 1. What would be the vertex of this one? What kind of 3? I put vertical. -3 and -5, because it's going to be opposite, because it moves the opposite direction. Because this is going to move left 3, and then this will make it move down 5. So that's how you want to think about it when you're trying to figure out what the vertex is. It's the opposite of what's in the parenthesis, but the same as what it is on the outside. So on the next slide, what I'm going to give you is things that are in standard form, and we're going to change them into vertex form to say what the vertex is. And guess what we're going to use? Completing the square. So let's look at those problems. Here we go. So write down the instructions and then write down problem 1. Now we're going to follow similar rules to yesterday, but they're not going to be exactly the same. So I'm going to do number 1, and then I'm going to give you a couple of minutes to try number 2, and then I will also do it. So what is our first step when we're solving by completing the square? A must equal 1, and move C to the other side is the second step. For this one, it would be move C to the other side since A is already 1. So when you move it over, it's going to become a -5 with the y, because you got to keep the y equals. We're not going to let it go away, okay? And then our blank's going to be on the right side, but it really doesn't matter. It's the same thing. We've just kind of switched sides a little bit. So we move C to the other side. Now we fill in the blank with using B over 2 squared. So B is, what's -4 divided by 2? And that squared is 4. So we're going to add 4 to both sides. Then what was our next step after we added? Factor. That's right, we got a factor. So now our factoring is going to be on this side. It's going to be something squared. What's going to be in that something? X minus 2. That's right. Half of 4 is 2. Square root of 4 is 2. So you can go either way with getting that number. And then on the right side, we combine like terms. The y is going to stay, but we're going to combine these two to make -1. Now, here's where it goes a little bit different, because we're not going to square root. We are now going to skip that step and just get y by itself. What would you do to get y by itself? Add 1. So it's x minus 2 squared plus 1. Is this in that vertex form? Yes, now it is, because it has something squared and then something added on the end. So really all that you had to do was move C and then figure out the blank to factor, get y by itself. So now that y is by itself, we know our vertex is 2, 1. Good, it's the opposite and then the same. All right, you guys take a couple of minutes, try number 2. If you are confused about the process, look back at number 1 and figure out what we did to get number 1. But you are just trying number 2. There's a trick in number 3, so don't try number 3 yet. right, while you guys are working it out on the paper, I'm going to go ahead and work it out on the board and just talk through it. So since A already equals 1, I'm going to move C to the right side or to the other side, which now is the left side, and put my plus blanks. So x squared and x are on one side, everything else is on the other. And now let's do our b over 2 squared to fill in the blank. So 5 over 2 squared. It's going to give us a fraction, so I saw a lot of you using your calculator, so that's great. Hitting your math enter. So we have 25 over 4 that we are adding to both sides. We're going to complete the square on the right side. So remember, square root of the last. So square root of 25 is 5. Square root of 4 is 2. Then over here, we're going to combine those like terms. Keep the negative with the 8. So it's negative 8 plus 25 over 4. Keeping it as a fraction is a great idea. So negative 7/4 will be on that side. And then our last step, get y by itself. And we're going to tack it on at the end, so that way it's in vertex form. Is that what you guys got? Okay. Are there any questions on that? Okay. So remember, remove C, fill in the blank factor, and then get y by itself. And make sure you have a negative. So make sure that's a negative 8 plus 25/4. So make sure you type in the calculator the right way. All right, so what's the vertex of this one? Good. Negative 5 over 2, because we do the opposite, and then 7/4. All right, let's look at problem number 3. And yes, there is a fourth one. Now, this one starts out with a number in front of x squared, so what do we have to do first? Divide that number out, right? We have to divide everything by 2, but we're going to end up dividing y by 2. Is that what we want to do? Do we want to divide a variable by 2? What's another thing that we could do besides dividing by 2? Something that starts with an F. We could factor out the 2. If there's a number in front of x squared, you really need to reverse a couple of steps. So I like how y'all were saying divide by 2, because that's normally what we would do first. But when we're manipulating these equations, dividing by 2 is not going to be as helpful. So what I want you to start off by doing first is let's go ahead and add that 18 to the other side. And then these things we are going to factor. Just those two terms, okay? So we're going to divide the 2 out or factor the 2 out because it is in front of the x squared. So we get 2, and then in parentheses, x squared plus 6x. Now, your plus blank is going to go inside. Oops, I forgot my plus blank on this side. Your plus blank is going to go inside that parenthesis, and then you have your plus blank on the left side beside that 18 because we moved that 18 over. So instead of dividing, we're going to factor it out. Now, do the same thing that you did to fill in the blank. So we're going to have 6 over 2 squared. Well, what's 6 divided by 2? 3, and 3 squared is 9. Now, here's where things also get tricky. Can I put 9 on this spot? Does that keep it balanced? The answer there is no. Because of this 2 here, it's really 2 times 9 that's added on this side. What is 2 times 9? 18. So over here, we need to put 18 instead of 9. So lots of tricks here if there's a number in front of x squared. So maybe draw those little arrows as a little reminder. Okay, now let's combine up those like terms together. So 18 and 18 make 36. On this right side, we're going to have a 2. The 2's still going to stay outside, and then we're going to have something squared. What's going to be in that something? X plus 3. That's right. The square root of 9 is 3. Half of 6 is 3. So you're just looking inside the parenthesis. Now, the same last step as this one, we're going to get y by itself, so we need to minus the 36. So now we can state our vertex, which would be that's it. So when you're manipulating these equations, if the x squared's just a positive 1, it's nice and easy, but if you have a number in front, you got to do some extra manipulation. So let's follow what we did in number 3 and do number 4. Let's do it together. You guys tell me what I need to do first. That's right. First, we want to add the 1 over. So it's y plus 1 plus blank. Then we are going to factor out the 3, right? We're going to take a 3 out of just these two terms here because that 1 is now moved over there. Okay, so if I factor out 3, I'm left with and then put your plus blank. So now we're going to complete the square. So we have negative 4 over 2 squared. What's negative 4 divided by 2? And square that? 4. So 4 goes in this blank, but we already know 4 doesn't go in the other blank. We're going to have to multiply by the 3. 4 times 3 is 12. So we get y plus 13, combining those like terms, equals 3. And then we're going to have some parentheses with a squared. What's going to be inside our parentheses? Very good. X minus 2. It's half that middle term, square root of the last. And now we got our last step, which is the easiest one. We're going to do what? Subtract the 13. And then we can state our vertex, which would be how much? Good. So you can see that these problems take a little bit of time, right? And there's a good amount of steps. So remember, show as much as you can so that way you can get some partial credit. Maybe you don't do all of this manipulation correctly, but you do label the vertex correctly. You'll get at least a point based on your equation, based on the vertex. So remember, it's the opposite of what's in the parentheses, same as outside. Oh, well, let's do a word problem, Lena, to help us know when we'd use it in real life. Eventually, it'll pop up. But in real life, if you are working like, it's used a lot in finances, quadratic equations are. So not necessarily that you would do it by hand this way anymore. A lot of times they have computers where, you type in the stuff and it spits out the answer for you. But if you are maybe writing a program for that finance department, you might use it. If you're a math teacher, you will definitely use it. But other times, it's more working through your math skills to get there. So that's what we're doing for the majority of people. All right, there we go. There is the question. If you want to just write down the equation, then we can write down some other things that go along with it. Like, we don't need to know what we're selling, but the equation is good to write down. And then I would write down that P stands for profit. and S is your selling price. So just those two things will help you out. There's the equation. P is profit. The selling price is S. So it says the profit P from handmade sweaters depends on the selling price from the sweaters. The function models the monthly profit. First, write the function in Vertex form, and then second, find the max profit and max selling price. So if you go, let's say we're going to like a vendor show, have outdoor little booths, and you see somebody there has these handmade sweaters. If the sweaters are sold for, let's say, $5, it's a great deal of purchasing them, but what does that say about the quality? It's probably terrible, right? They're selling handmade sweaters for adults. It may not be great. What if the price tag on them was $120? It's good quality. Would you purchase it? No. So there is a comfortable price and a comfortable profit. And all of that depends on problems like this. So if you're going into any kind of like business model, this would be a type of formula that would show up. Now again, computers would do a lot for you. But the first thing that we want to do is we want to write this function in Vertex form. So we're going to do the same thing that we did on the last few problems. Now I know a lot of you do not like S and P, so you can change them to X and Y like I have done here. Now what is in front of X squared? A negative. So what do we have to do? We got to factor out the -1 first, but we also want to move C to the other side. So let's go ahead and add that 2,000 to both sides and put a plus blank. And then over here on the right side, we're going to factor out that -1. Now remember, we're factoring it out of just the two terms that have X in them. So if I take out a -1, it's going to change our middle term to -120x. So if you factor it out, it's like dividing it out. Just do a quick double check. If you distributed it back, would you get the same thing? Okay. Now we're going to fill in for that blank using our b over 2 squared. So what's -20 divided by 2? And then we're going to square that number. How about, I think it's 3,000. 3,600. There's 2 zeros. Now, once that number goes here, how do we figure out what goes in this blank? That's right. You got to distribute it back. So you're going to multiply it by -1. So this will be a -3,600. So why? Now we're going to put these two together. So what's 2,000 minus 3,600? -1,600 equals -1. And then we have our parentheses with our squared. What's going to go in our parentheses? X minus 60. Good. It's half of that middle term or square root of the last. And last step, get y by itself. So -1 parentheses x minus 60 squared plus 1,600. So now we have written that in the Vertex form. So now we're going to find our max profit and max selling price. But we can do that by just picking out our vertex. What's the vertex of this? Good. 60 and 1,600. Now, if we go back up into our original equation, S is in the same place as what variable? X. So this 60 right here is the same as S or X. And then the second number would be P. P. So what did S stand for? Selling price. So we would sell our sweaters for $60 per sweater. And then we would end up with a max profit of $1,600. That makes more sense than the reverse, right? It'd be nice. Hey, I'm going to sell my sweaters for $1,600 a piece. I don't think I would sell any. Maybe if I put my picture on them. Maybe that would work. All right, any questions so far? Okay, our next word problem comes from this worksheet, so I'm going to pass this out real quick so that way you don't have to write all this down. Don't get too curious about the backside. The backside is actually your homework tonight, but don't flip over there yet. Remember, it's not due until Thursday, though. But this is our last problem that we're going to do, and then you guys will have a chance to work on your homework. So there's two. Just pass one to Dixie. There's two. Pass one to Melanie. They're all sticking together. Or Melanie, just grab your own worksheet. All right. Hayden, pass those worksheets down. It's kind of funny. All right, how many people love sports? Yeah, we're at the early college. There's not many. All right, here we go. We are looking at kicking a football. It says the height of a punted football can be modeled with this quadratic equation. The horizontal distance in feet from the point of impact with the kicker's foot is X, and the height of the ball is what H is. So if we look at our formula, H is in the same place as Y, so this is the height of the football. So just the height of the ball. And then it told us that X was that horizontal distance from the kicker's foot. So this is distance from the kicker. Sometimes it's a great idea to label those XY axes so that way you know what they mean later on in the problem. So part A says find the vertex of the graph by completing the square. I'm going to start up here because I write a little bit bigger than that space, but you can put yours anywhere. And I'm going to write down this equation with X and Y in it. We're going to have to use our calculator to maybe find some of these values for us. So what's the first thing that we're going to do? Subtract the 2. So Y minus 2 plus blank equals. Now, what are we going to have to do from here? Take out that negative 0.01. We're going to have to take that out. We're going to have to factor it out to keep the x squared positive. Now, when you factor something out, what operation are you actually doing? Division. So to figure out this middle term, we're going to divide 1.18 by negative 0.01. So let's grab our calculators. 1.18 divided by, you can have it look the same way it looks on your paper, negative 0.01 gives us negative 118. That's a better number to deal with, huh? So negative 118x plus blank. So when you factor something out, it's really like division. You can divide those two numbers. Now we're going to fill in our blank by using our b over 2, bless you, squared. So 118 divided by 2 is 59. And so what is 59 squared? 3,481. Okay, remember that number goes in the blank, but we have to figure out what goes in the blank over here. What are we going to have to do? You got to multiply these two numbers to to figure out what goes there. So let's multiply that by our negative 0.01. Negative 34.81. Sorry, I kind of ran out of room in my spot there, didn't I? And now let's combine those like terms together. So y, both of these are negative, so if we put those together, it's minus 36.81. Is that right? And then equals negative 0.01. And now we have our parentheses squared. It's going to be x minus, what number is going to go there? $59. That's right. It's half of that middle term if you want to do it that way. Or also the square root of 3481 should be 59 as well. And then last step, let's get y by itself. So we are going to add that 3681 to both sides. So the formula, if we go through and complete our square, is this one. So that would go there. That would be the formula for it. But this one said find the vertex. So the vertex is now the next question deals with the vertex. Anytime it asks for a max or a minimum, it's asking about that vertex, but it's probably asking for a specific part of the vertex. So it says, what is the maximum height of the punt? If you look back at what you put on your XY axis, we're actually looking for what value? The Y value. The Y value was the height. So what is the maximum height of the punt? Good, 36.81, and whoever said feet, thank you, because remember when we do word problems, we attach units to them. So part B is 36.81 feet. Now, part C says the nearest defensive player is 5 feet horizontally from the point of impact. How high must the player reach to block the punt? So if we look back at this picture, it's kind of drawn in for us, right? Here's the defender running. He's at 5 feet away from the kicker, which means he's at what value? X equals 5. We want to figure out how high must he reach to block that punt. So we need to figure out the Y value if we are given the X value. So in this particular question, we are given X equals 5, and we want to find the Y value. So how are we going to do that? Plug it into the equation. It shouldn't matter if you plug it into the original equation or the vertex equation. You can plug them in to either one. So let's plug it into that original equation first. So we have negative 0.01, and then it is x squared. So I'm going to put 5 in parentheses. The squared always goes outside the parentheses. Plus 1.18 times 5, and then a plus 2. Now, again, if you wanted to plug it into the vertex form, you could use that as well. So it would be x minus 59 squared plus 36.81. And notice you get the exact same answer. So you must have done the problem correctly. So the answer here would be 7.65 what? Feet. So if he can reach up a little over 7.5 feet, he can block that punt. All right, part D. Suppose the ball was not blocked but continued on its path. How far down the field will the ball go before hitting the ground? And I gave a hint here. Hint is to solve for x. Also another hint, the y would equal 0. That's another hint for this. You're going to put 0 where y is, and you're going to solve for x. Now, you actually have two ways that you can solve. You can use the original equation and solve with the quadratic formula, or you can use your new equation and solve with using square roots and complete the square. So do you want to solve quadratic formula? You want to solve the vertex with complete the square? Okay, let's take a vote. Quadratic formula? We got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, complete the square? Well, I only got 3, so we're going to go quadratic formula, but y'all can do complete the square, see if you get the same thing. All right, if we're using our quadratic formula, we pick out A, B, and C, so this would be of the original problem. So A would be negative 0.01, B would be 1.18, and C would be 2. And then let's sing our song. X equals opposite of B plus or minus square root B squared minus 4AC all over 2A. Now, what's good about word problems is, do we need to like break down square roots and make an exact answer? No, we actually don't have to do that. We can just simplify as much as possible though still. So still do the same things that we did before. We're still going to simplify our denominators. So 2 times negative 0.01 would be negative 0.02. And then simplify what's under your square root. Type it in your calculator exactly how it looks. You guys know how to do this because y'all did great on doing that on your quiz and your homework. Just make sure that you put 0.01. That was my big mistake, I think, before. And you can just round this number to 2 decimal places. Everything that you get out, you can round to 2 decimal places is perfectly fine. Now what we're going to do is just divide these two numbers out. Keep the plus or minus, but just go ahead and divide. Negative 1.18 divided by negative 0.02 is 59. We've seen 59 before, haven't we? It was the vertex part. That's always going to be the same, the x part of your vertex. Then that plus or minus. Now, when you type in this next part, type in the square root and remember to either right arrow or you can hit enter and then divide by 0.02. So I got out negative 60.62. So again, when you type in that second part, it's square root of 1.47. Make sure you right arrow before you hit divided by negative 0.02. Or you can do the square root and then divided by negative 0.02. You can separate it into 2 steps if you want to save your calculator from any issues. So our last step that we would do is split this into 2 problems and combine those together. So what's 59 plus negative 60.62 and 59 minus negative 60.62? Oops. So I got negative 1.62 and 119.62. So again, just round everything to 2 decimal places, then go through and simplify as much as you can. Now, the question says, how far down the field would the ball go before hitting the ground? Are we going to use the negative answer? No, we can't go negative distance, so it would be the positive distance there on the right. Any questions? Y'all ready for the last question? Okay. The last question says that the linear equation h equals 1.13x plus 2 could model the path of the football shown in the graph. So if I were to look at the graph, that linear equation models this part right here that the ball is being kicked. Is that a good model? Or why is this not a good model? Why not? The ball's affected by gravity, so a linear equation keeps going on forever and ever and ever, right? But what's going to happen to our football? It should go back down. So you can write a little sentence about that if you would like to, but it is not a good model because linear equations go on forever. All right, if you flip over to the back side of this worksheet, the back side is your homework that you have. The first couple of problems, you are manipulating the equations to put them in Vertex form. And then down here at the bottom is kind of a review of each type that you have. Now, although you have 25 minutes, some of you might can finish this in this time period, but if not, we're going to turn this worksheet in by Thursday. So you got 2 nights to do it, and you have some more work tomorrow as we review for our test. Any questions? Okay.